Hi everyone, hopefully you can use these video solutions to help you through the homework. Let's start with number 5. So find the determinants by row reduction to echelon form. So here's the matrix: 1, 5, -4, -1, -4, 5, -2, -8, 7. And so we are going to try and transform this into something that's a triangular matrix, and then we'll use the elements on the main diagonal to find the determinant. So my first operation I'm going to do is let's see, row 1 plus row 2 and put that in place of row 2. Then I'm going to do 2 times row 1 plus row 3 and put that in place of row 3. Oops, place of row 3. Okay, so first row is staying the same. So 1, 5, -4. This row is going to become 0, 1, and 1. And the next row is going to become 0. Let's see, 2 times 5, and then it's going to be 2. And then 2 times -4 plus 7, that's going to be -1. So those two steps did not change the determinant because they were both adding steps. And we're going to do one more. We're going to do -2 times row 2, add it to row 3, and put that in place of row 3. So 1, 5, -4, 0, 1, 1, and 0, 0, -3. So we never did any row interchanges. So the determinant of the final matrix is the same as the determinant of the original. So we can say that the determinant is -3. I'm just going to check that real quick with the solutions. Yep, that's correct. Okay, going on to 15. So here we're given the determinant of the matrix with letters A, B, C, da, da, da. And then for 15, they're just going to do an elementary row operation, and we have to talk about how the determinant changes. So when we multiply a row by a non-zero constant, that gives us the determinant times that same non-zero constant. So number 15 is 21. Number 16 is same situation, so it's going to be 35. Number 17, we're taking row 1 plus row 2 and replacing it, so that's going to have the same determinant as the original. So we've got 21 so far for 15. We have 35 for 16 and 7 for 17. For 18, we have interchanged the first and second row, so our determinant gets negated, so that's -7. For 19, we're taking 2 times the middle row and then adding the top row. So we have actually doubled the second row, so we'll double the determinant, so that's going to be 14. And then in 20, we're doing the second row plus 3 times the third row, so it's going to be the same determinant. It's going to be 7. Okay, for 21, it tells us use determinants to find out if the matrix is invertible. The matrix is 2, 6, 0, 1, 3, 2, 3, 9, 2. Okay, so first step I'm going to do is interchange the first and second rows. And that has the effect of negating the determinant, so we'll keep track of that. Then we will begin row reduction by doing -2 times the first row plus the second row. So we've got 0, 0, and then let's see, -2 times 2 plus that. Okay, so that's going to be -4. Then we'll take -3 times the first row plus the last row, so that's going to be 0. And a 0 here, and then -4, right? -3 times 2, yeah, -4. Okay, so we can tell right away that there are 2 rows that are the same, which means this is going to end up having a row of all zeros, so our determinant's going to be 0. So if we could do one more step, it would look like this. 0, 0, 0. And now it's triangular, so the product of the elements on the diagonal is 0, so our determinant is 0, which means that the matrix is not invertible. Okay, that's 21, 25. Use determinants to decide if the set of vectors is linearly independent. So it's only going to be linearly independent set if the matrix is invertible, and that's only true when the determinant does not equal 0. So we'll put these vectors in a matrix, and we'll find the determinant, and then that'll determine whether or not we have an invertible matrix or not. I'm going to do cofactor expansion along the last column. So we'll say 7 times the matrix -4, 5, the determinant of this matrix, negative 6, 7, and then plus negative 5 times the determinant of 7, negative 8, negative 4, 5. Okay, so this is going to be 7 times negative 28 plus 30 minus 5 times 35 minus 32. So we have 7 times 2 minus 5 times 3. So we don't really care what the answer is. We just, I mean, it's negative 1, but all that means is that the matrix is invertible, which means the columns are linearly independent. So we can stop there. All right, 27 and 28 are both true, false. So let's look at each of those. A row replacement operation does not affect the determinant of a matrix. A row replacement operation does not affect the determinant of a matrix. Okay, so that kind of depends on what they mean. So row replacement is the kind where you're doing like 2 times row 1 plus row 2 and put that in place of row 2. So A is true. That operation does not affect the determinant. B, the determinant of A is the product of the pivots in any echelon form U of A multiplied by negative 1 to the R, where R is the number of row interchanges made during row reduction from A to U. That is false because it doesn't account for the possibility of scaling. So B is false. If you scaled a row by a non-zero constant, that would mess with the determinant. If the columns of A are linearly dependent, then det A equals 0. That's true. If columns are dependent, then we have a non-invertible matrix by the IMT. So det A equals 0. And then det A plus, yeah, that's false. We haven't discussed that formally yet, but we will. Okay, and then 28. If 3 row interchanges are made in succession, then the new determinant equals the old determinant. That's false. If there were 3, 2 of them would cancel out, and the third one would make it positive, or would make it negative. The determinant of A is the product of the diagonal entries of A. No, that's false. That's only true when the matrix is a triangular matrix. So B is false. C, if det A equals 0, then 2 rows or 2 columns are the same, or a row or column is 0. No, that's false. If det A equals 0, then we know that the columns are linearly dependent, but they don't have to be the same. One would be a linear combination of the others. And then determinant of the inverse is negative 1 times the determinant of the original. That's false as well. We haven't formally talked about that, but we will soon. Okay, hopefully that was helpful. I can take more questions in class.